Okay, in our last sessions we set up the ports and the clients. Now let's run our first packet loss test. So under the application suites, we choose packet loss. We've already configured the port, and we've configured one Wi-Fi client and one Ethernet client. Each of them is set up to get an IP address from the device under test. In this case, it's a simple access point. It's a Netgear 802.11 AC access point, and our Ethernet side is connected to one of the LAN ports, and the Wi-Fi side, of course, is connected to the Wi-Fi port through 30 dB attenuators. So if we go to the test page, and as I mentioned before, we're going to work our way down the left-hand side of this page. So we configured ports, clients, and now we're doing test. So this test parameter page is common to many of the different applications, and so is the advanced test parameter page. So as you change between tests, you may want to go back and change what's printed out in the report to match whatever it is you're doing. On test parameters, we have trial duration. In all cases, that means whenever we begin running traffic, the length of time that the traffic will be run is the trial duration. Now, if we run traffic for 30 seconds, we could repeat that by increasing the number of trials. We'll come back and talk about loss tolerance when we go to the throughput test. The next two items are the settle time and the aging time. So remember that pretty much every test that we're running traffic from one card through the device under test to another card. And so what the settle time means is we have a transmitting card and a receiving card in every case. In some cases, traffic is going bidirectionally, but let's think first about the simplest case. Let's say we're running from our Ethernet card into the Ethernet port of the access point and out the Wi-Fi side of the access point into one of our Wi-Fi cards. The settle time would be the length of time where we would wait to capture statistics after stopping the traffic. Now, to say that a different way, let's say we're running a 10-second packet loss test. So we will configure the Ethernet card to drive traffic for 10 seconds. And then after we stop the traffic on the Ethernet card, we will wait 2 seconds, the settle time, before going to the Wi-Fi card to ask the Wi-Fi card how many frames it received. This allows for any buffering in the device under test to be emptied out, so that all the packets that were generated, if they got stored temporarily in the device under test, they have an opportunity to come out. Aging time is just after a trial is done, how long after the settle time do we just sit and do nothing and let the device under test rest? Now, these default to 2 and 5. I typically set them to much less than that, like 1 second each, because if you have to increase these numbers in order to get reliable results, it's an indication of a problem in the device under test. But we'll leave them at 1 second for this point in time. We'll come back and talk about the rest of these things at in another session. We're just going to run our first simple packet loss test. So we'll run for 10 seconds. The advanced test parameters, this is just where we put in information that we want to be in the comma separated file or to print out in the PDF report. So we can enter the AP model and AP switch version and things of that nature. Now, these two tabs are typically the same or very similar across all of the different application suites. This tab will change every time you choose a different application suite. So here we've chosen packet loss. So we'll go to packet loss properties. We can run the default, which will choose a variety of different frame lengths, the payload lengths, in order to run the test, and it will run each one of those across all of the choices of the load list. Now, that's fine, but what I'll do for the first time is just single out a particular frame size, 1518 byte frames, and we're going to run upstream. So let's put in 100,000 packets per second. In the upstream direction, we should never see any frame loss. We'll just try this once. So 1518 byte frames, 100,000 packets per second is the load. Then the last thing we choose is the mapping. Where do we want the traffic to run? So we're going to choose wireless to Ethernet. Okay, at this point, we are ready to click the green button and cause the test to run. When we do that, the application is going to write down to the chassis everything that the cards need to know in order to run the test and run the test. Now we can watch what happens as we go along here. First, we're going to make sure that the wave test firmware on the laptop that we're running matches the schema of the firmware on the chassis. And it does. Then you're going to notice that we adopt the AP's bandwidth, we create the clients, then we connect the clients. You can see that they got connected up. Then we ARP through to make sure that communication can occur from one card to the other. I'm going to dismiss this for just a moment and come back. So ARPing through means we have generated an ARP request off of the Wi-Fi card. It has gotten through to the Ethernet card and we've gotten an ARP response back. This ensures that we have end-to-end communication before the test starts. If the ARP fails, the test won't run. And now you'll need to go figure out what's wrong. Typically, that's an IP addressing issue. Then it comes to trial number 1. Transmitting 1518 byte frames at 100,000 packets a second is what we set up. We would see the time log showing the time counting down, and here we got an answer of 987 megabits a second with 0 frame loss. And we waited 1 second for the recovery time, and then we went and printed the report. The report that comes up will have the date, if we had put any information in on the device tested. Here's an overview. This 0 means there was 0 frame loss. This is a packet loss test, so it was checking to see if there was any loss. The next graph down will show you what the offered load was and what the actual achieved load was. So you can see here that we offered 81,308 packets per second, and all of those got forwarded out the Ethernet port. We can also see that the medium capacity, what the theoretical max is printed with this blue line. As we go through the rest of the report, you can run one of these tests and look at the report yourself, but the details of what our intended load was, what our offered load was, and what the forwarding rate turned out to be is all recorded here. Now those 3 items are very important when we think about all of the tests that we're going to run. The intended load is simply what we ask the traffic generator analyzer card to do. The offered load is the packets that were able to be transmitted and acknowledged across the Wi-Fi interface. And then the forwarding rate is what got to the other end. So in this case, we were running Wi-Fi traffic upstream. We can see that in the report. If we go back up a ways, we can see the direction here. So we had this card, so Wi-Fi card, pushing traffic to the system under test, and then an Ethernet card that was a receiver of the traffic. Okay, so the intended load we set in this card was 100,000 packets per second. It will attempt to produce 100,000 packets per second. The aggregates that it sends out have to be acknowledged. All the frames have to be acknowledged. So the rate at which this card will successfully be able to submit frames to the SUT will be based on how quickly the SUT acknowledges and if there are any missed acknowledgements. So we can dial up a very large I load. That doesn't mean that that load is going to get offered to the SUT. Only what the interface can allow will be what the SUT experiences. But in the Wi-Fi world, when we send a packet, we do not count it as being offered to the network under test until it has been acknowledged. Because in 802.11, we would have to do a retry or a number of retries. And then once we see that that packet has been offered to the SUT because the SUT has acknowledged it, only then do we count it as a part of the offered load. The achieved load or forwarding rate is what comes out the other side. So in this case, we've recorded the intended load, the offered load, which is what got onto the wireless interface, and then what the forwarding rate was, and we see that those two match. And it's not a surprise because we've got a gigabit Ethernet interface and less than a gigabit Wi-Fi interface. Okay, so that's running your first frame loss test. While we are here, I'll point out a couple of other things in the test category. You can choose a variety of different frame sizes. You can set an increment system up where you can choose a minimum and a maximum frame size and the step size between them. This is good from an analysis point of view to do a short frame loss test on every frame size just to make sure that every frame size works through your device under test, and you can choose your frames per second. The frame loss test is one that is used frequently during diagnostics. If something's not working right in a throughput test, oftentimes it's difficult to interpret the packet capture because there's a binary search going on and so many things that are changing. A very simple way to get a clean packet capture is to choose a particular packet size, a single intended load, and then go back up here and save that hardware log after the test. We will do that in our next session.